lecture we will talk about the IR spectroscopy. So let us start from the spectroscopy first. What is spectroscopy? It is actually the interaction of the electromagnetic radiations with the matter. When electromagnetic radiation interacts with the matter, this is called spectroscopy. And this interaction of the matter with the electromagnetic radiations is of different types. Okay, this interaction may be in sense of absorption, transmittance, emission, or etc. Means our matter can interact in different ways. So in short, when electromagnetic radiations interact with the matter, this interaction is called spectroscopy. That's it. Now let's move to our next point, that is IR. What is IR? IR is actually the electromagnetic radiation of a specific range, having a specific wavelength and specific frequency. You know, electromagnetic radiation is composed of gamma rays, X-rays, UV, visible IR, and etc. So IR is having a specific wavelength and specific frequency. Wavelength is 1 millimeter to 700 nanometer, and frequency is from 430 terahertz to 300 gigahertz. That's it. So this is actually the radiation of specific range. In short, IR is the radiation of specific range. Now let's come towards the very point, IR spectroscopy. You got the concept of spectroscopy. Electromagnetic radiation when interacts with the matter is called spectroscopy. Now just remove the word EMR from here and put the term IR. When IR interacts with the matter, this kind of interaction of the IR with the matter is called IR spectroscopy. Very simple. When IR interacts with the matter, so such kind of interaction of IR and matter is called IR spectroscopy. That's it. Very simple. So again, I have written these words here. If we use IR as EMR, then it is known as IR spectroscopy. Now let's come towards the next point, that is the use. What do we use this spectroscopy for? The very use is that it is used for the identification of functional group in a molecule. When we have a molecule, and in that molecule, if we want to find the functional group, then we will use IR spectroscopy. And now here I mentioned the word molecule. So this spectroscopy is functional when we are studying the molecule, and more specifically when we are finding the functional group in a molecule, we use IR spectroscopy. And let's come toward the next point, that is the principle. What is the principle of IR spectroscopy? Now just understand the word principle. What is the very way through which this IR spectroscopy is functional? That is absorption and transmittance. Now the principle, you have to take this principle from the sample. Now this IR, the way the IR is interacting with your sample, that is actually the principle. So now we will study that how our IR is interacting with the sample. Our sample will actually absorb and transmit the IR. So due to this, the principle will be absorption and transmittance. Don't confuse yourself. What is the principle? The principle is the absorption and transmittance. Now this principle will tell us that how our IR spectroscopy is functional, or how our IR spectroscopy works. So principle is absorption and transmittance. So this specific particular principle, our IR spectroscopy will work. And now I have mentioned here that note. You can write a theory of the working in the principle. Sometimes the teachers, they compel the students that you have to write the theory of the working in the principle. So I don't compel any of my students, and I don't want my students to be stereotyped. Please remember one thing. What is the word, the term saying, write that thing. And working is the explanation of the same principle. If you're writing, write it down. But I recommend principle just to be one line, that is absorption and transmittance, because this is the principle through which our IR is working. Now let's come towards the working. Before working, we must know about the instrumentation. Then we will move towards the working. In the instrumentation, we have IR source, sample cell, in which we will place our sample, monochromator, also known as filter, and a slit detector, readout device. This is the instrumentation of the IR spectroscopy. Now let's move towards the working of the IR spectroscopy. We'll take the IR source. We can take any of the IR sources that we have, like tungsten filament lamp, nichrome wire, etc. So you can use any. Okay, so here we are using the tungsten filament lamp as an IR source. Now we will target the IR radiation on the sample, and the sample is going to absorb and transmit these IR radiations. So what will happen? It will absorb some of the radiations of the IR, and the rest will be transmitted. Now this transmitted IR radiations will move through the monochromator, then through the slit will move towards the detector, and the detector will detect these photons from the IR, and the detector will detect these IR photons, and then the result will be shown on the readout device, and that will be in the form of this graphical representation, in which we have percentage transmittance, wave number, and this graphical representation has absorbance region and fingerprint region. Now let me make you people understand more through the example. Let's say we have IR radiation. When we target these IR radiation on a specific molecule, here our molecule is considered as formaldehyde. So I mentioned this formaldehyde in my Urdu lecture, that's why I am going to present this example again in my English lecture also. So what will happen when the IR is targeted on the sample? This sample will vibrate. What will happen to the sample? This will vibrate. Now remember again, when we were targeted IR radiations on the sample, some of the radiations they transmitted and some of the radiations were absorbed. The very reason behind is that wave number. Our molecule is going to absorb a specific wave number of the IR radiation, and the rest of the wave numbers of the IR radiations will be transmitted. So that specific wave number will be absorbed by this molecule, and the molecule will vibrate. After vibration, what will happen? Vibration in the molecule is of two types. That is either bending or stretching. And there is explanation available of the vibrations, mean about the bending and the stretching. There we do have different types of bending and stretchings. If you guys want us to make the video about this, so you have to type in the comment box. Otherwise, it is very simple. You can guess, you can read it from any source. You will understand. Anyway, let's come towards the point. So when IR is targeted on the sample will vibrate, and this stretching and bending will be observed in specific regions. The bonds present will show actually the stretching. Here is the bonds. The bonds will show the stretching, and the atoms, or you can say the skeleton of the molecule, that will show the bending. This is the very point that you must remember. Stretching is specific for the bonds will stretch, and the bending is specific for the atoms, or you can say the skeleton of the molecule. So what happens in the graphical representation when IR is targeted on the molecule? So some of the wave numbers will pass through the molecule, that will produce our transmittance, percentage transmittance, 100% transmittance, and some of the IR wave number that will be absorbed by the molecule, and they will show this absorbance region, and absorbance peaks at specific wave numbers. So like this absorbance region will be formed due to the stretching of the bonds, and the fingerprint region will be performed due to the bending of the atoms, or you can say the skeleton. So now how will we identify our specific functional group to this particular graphical representation? Very simple. We have two things. One is spectrum library, another one is reference list. So now this absorbance region, we will compare the reading from the absorbance region with the reference list, and we will compare this fingerprint region with the spectrum library. Like this, it will help us in finding specific functional group and the atoms present in that functional group. So this is how our IR works. And if still you have any kind of question in this topic, you can drop that in the